Hello, November 14th. All right, let's do this. Count the number of substrings with dominant ones. Dominant ones. You are given a binary string. Return the number of substrings with dominant ones. A string has dominant ones if the number of ones in a string is greater than or equal to the square of the number of zeros in the string. Okay, the substring with dominant ones are shown below. So we have 0 number, okay, 3, 3, 4, 4, 1 number, then we just need to have 1 or 2. So 2, 3, and okay, and then we have 1 number, so we just need to have 2. But 2 number we don't have. That's kind of misleading you, but let's see, what's the length? 4 times 10 to the 4th. So we should be like, 0, 0, right? 1, 2, 3. Then we need just count of 1 is large equal to 1, right? 1 is also large equal to 1. That's the same. That's the same, because if you go 1, square is also 1, and then you need to have a larger number of ones, like this. Yeah, I have a number of ones. But if you have 2, then you need a large equal to 4, right? Number of equal to the square of the number of zeros, right? So square is so these are the non-dominant ones. It's kind of giving you different ideas. Maybe we can go with the non-dominant ones. But I feel this should be the same, like this should be larger than 9, right? But anyway, that's another point. The point is because it's substring, right? It's substring. We have a substring. And we know where all the ones are, right? When all the ones are, so I can get all the ones out. I can get all the islands of 1 out. Okay, so these are the islands of 1s, and then they're having zeros in between. Okay, they have zeros in between. Okay, we have islands of 1 and a 0 in between. So in this case, we have 1, 0, right? We have 1, 1, 0, and a 1. So island of 1s. So then, for each island, we can say 0 count is 0, then this is going to be 1, this is going to be all the substring, which if it length is n, so it's m plus n minus 1 plus 1, so it's n plus 1 times n divided by 2. So this is 0, 0. So this is going to be 1 plus, this is going to be 3 times 2 divided by 2 plus 1. It is going to be 5. Okay, so now I have 1, 0. Right? We have 1, 0. So if I have 1, 0, I need to be, so I go to Do I go to a 0? Okay, so I go to a 0, and because I need ones, so I cannot go to the 0 in the middle. So so this is the group of 1, there's another group of 1, there's another group of 1. So I go to the group of 1 and then expand to the right. Okay, so I have a 0 here. So whatever I have here, they will just add. Actually, that's not true because we must have this 0, right? So it has to be 0 with this, 0 with this, 0 with, so it's just the number of count. So this is going to be 1. And here the same, I have a 0 here. Oh, we also have cross. Damn. Yeah, so we have to go on both sides. Okay, so on one side, on the other side, holy crap. On one side and on the other side. And you can cross multiple zeros. Maybe we should consider from 0. So we do the ones first, right? And then we say, okay, I will start from 1, 0. So I know where the zeros are, so I get a 0. And then I say, okay, I'll include all the ones to my left until I hit another 0. So yeah, so I get a 0. And then I look to the left, I got everybody there. Okay, so I can have it. And then I look to the right, okay, and I have it. And now I'll combine both left and right. So for this 0, I have 1, and this is going to be 2. And we're going to have 1 from here, 2 from here, 1 times 2, and I have 2. So that's for this 0, right? And then we have, for this 0, it's the same. I have 1, 2, and then 2. So this gives me 10. This already gave me 10. Right, 11, 12, 13, 14, 15. That's already give me 15. And then we say 2 zeros. Okay, so I have 2 zeros. So, because I'm gonna do just index for the 0 indices. Okay, so I just do this to find out the same, because I can just count the left, count the right. We have the thing in the middle, so I know how many we need on the left, how many we need on the right, and then move on to the next side and move on to the next. Right, and now we have 3, and now we have 4. There's a chance that we might time out. S length is quite big. And as we move on, we need to make sure we don't have to recompute. Right, so like I have this, a bunch of zeros, right? So I compute how much we need. And then when I move on, basically I move on here. But it's fine. Like I say in between, I'll know what's in between. I don't even need to know in between, because when I move on, I know this index, I know this index, I know how many in total, so I know how many ones in between, right? And then I know how many ones we need on the outside, right? How many, like at least, that we need. Like additional we need on the outside, and then it's like only only in this range and only in this range. It cannot get another one. So yeah, I know how many in here, so I can do the computation. Okay, so yeah, but I feel like it's gonna be a lot if I just do that. So if there are a lot of ones, then I can do this way, right? If there is not a lot of ones, there's a lot of zeros, then we will terminate. So I count the number of ones, right? I'll count the number of ones, and we will stop. The number of one has to be larger than the square, the number of zeros. So once we hit a number of zeros not too large, okay. Okay, there's also more. Like if you have a bunch of zeros together, right? And you can just skip, because like let's say we want 2, right? We want 2, and the zeros only at the edge. Okay, the 0 can only be at the edge. Well, because we need to work on the gap. So we have this, right? So we see there is, yeah, we just see to the right, like if there's anything in it. If there's no 1 in it, then it's just gonna be 0. Like I expand this way, it's gonna be 0, and I expand this way, it's gonna be 0. And in between is going to be nothing, and then it's not possible. Okay, we can try, see how it goes. I might have done other things too much, and then it's kind of, I feel tired. It's like a theme. It's like every day I'm repeating this. I say I feel tired. Every day is tired. Let's say we'll count from the perspective of zeros, right? So we can start with no 0, right? We start with no zeros, then with 1 0, 2 zeros, right, and so on. And we will create an auxiliary array to hold the indices of all zeros. I'll say O(n) squared, but I hope it will not get to that. But it should not get to that, because the requirement is the number of ones must not be smaller than the square of the number of zeros. This means the loop on the 0 count can only go to sqrtn. So basically O(n) times sqrtn. Okay, So we'll do vector int 0 indices. If si is equal to 0, 0 indices dot push back I. Okay. So we have also we need to check the total count of ones. So we can say int 1 count 0. Okay. Say we can say else 1 count plus plus. Right? Okay, 1 count plus plus. Then we just go for int z count is equal to 0. Z count times z count, right, is smaller or equal to 1 count, and the z count plus plus, right? So for each one, I think zero is a special case, right? I think 0 count is a special case, so we'll do int res equal to 0. Handle 0 count on 0. Basically, we just for int I equal to 0, I smaller than 0 indices dot size, I plus plus. We basically, for this, I'll look to the left, look to the left, look to the left, and the last one will look to the right. Yeah, that's what we're gonna do. The last one will look to the right. So what we're gonna do is we look to the left. Okay, everybody look to the left. So I need to know the count. So int c, like total 1 count. So here we say 1 count shall equal to 0 indices I minus I is larger than 0. Then we say 0 indices I minus 1. Right, it's the previous index. So the 0, 1, 2, 2 minus 0 actually the minus 1. Right, otherwise we is just going to be 0. Right, it's like 0, 1, 2, and then minus 0. Yeah, so that's the 1 count. And we say res or plus equal to is going to be this times, actually I think it's OC plus 1 times OC divided by 2. Right? And then we'll move on. We move on. And then we go to the last one, and then with the last one should be res or plus equal to. Actually, I'm gonna do this. OC is equal to 0. Alright, so I don't redefine it. And here I say OC shall equal to s dot size minus 1 minus 0 indices dot back. Okay, 0, 1, 2, and then minus 1. And then res plus equal to, I have res plus equal to already, plus equal to, OC plus 1 times OC divided by 2. Alright, so this now handle 0 count from 1 until it blows up. Okay, so now here I can make it simpler. So 1, right? It's smaller than total this. Okay, so for each count, I have int I is 0, and for int j is j is 0, j is smaller than 0, and this is the size, and j plus plus. Okay, so j and I, actually I don't even need this. I think I is sufficient. Right, that's sufficient. So when we have I, so every single time when we have it, we need to know the, actually we can say low and high. Okay, so this is a high. Yeah, I think this will be simpler. This is a high, right? And the low shall be high minus 1, 2, 3. That's 2, 3 minus 2. So this one minus count. Plus 1. Alright? So like 0, 1. Let's say 0 and 2. Oh, that's actually not right. That is actually... Oh, hold a second. This is 0 indices. Right? 0 indices. So if it's 1, if it's 2, minus 1 plus 1. Yes, that's correct. So there's a low and a high. Okay. And then we'll say one in between. Right? One in between shall be 0 indices high minus 0 indices low. Right? 0, 1, 2. So if it's 0 and 2, then 2 minus 0 is 2 minus 1. Okay, this is in between. Right? And then we'll find the max allowed on the left. Max allowed on the left, max allowed on the right. And then, oh, maybe there's a formula. Let's say we have 5. We allow 5. So we're gonna do like 1 times 4, 2 times 3, 3 times 2, and 4 times 1. And of course we have 5 on that. So we have 5. So we have the number here. We have the number here, right? And we have the number in the middle, so we know what's the minimum amount we need to have here. The minimum amount, right? The minimum amount. Let's see. We have the minimum amount. Let's say the minimum amount is 5. We need to have 5 in here, right? So we get a total with this plus this. If it's smaller than 5, then it's not possible. We just move on, right? If it is possible, it's possible, then, well, we first check on this side by itself, is it possible? Then we check on this side by itself, is it possible, right? So we get that, and then we say, put together, is it possible? And the answer is yes. Well, we can put together. Now we just need to figure out how do we structure it, right? How do we structure it? Like if I do 1 here, do we have 4 here? If I do 2 here, do we have 3 here? Right? So on this side, I see how many more do we have? Okay, and then yeah, I have the count here. I have the count here, and I do the maximum count. Yeah, but I don't involve this. I just do this. I do this. Okay, and then we say we needed a 2. So I say if I only have 1, do we have? So this kind of the limit is not 5. But let's say the limit is 4. So how many can we get beyond 4? Right? I can take 1, and then I need to take however many. Then I say I can take 2 on this side. I'll take however many, and I'll take 3. So all the way until this. I mean, we can actually say start from taking 0, right? Taking 0. So it's just this minus this, right? This minus this. That's the number we get. So let's say we have x here and a y here. So if I take 0, this is going to be the maximum of 0, and a y minus, let's call this is 1 in between, right? 1, I call it OB, 1 in between, right? 1 in between. And then if it's 1, then it's going to be the max 0, y minus OB minus 1. And I have 2, it's going to be max 0, y minus OB minus 2. Right, and then eventually it's going to be x. And then this is going to be a maximum of 0 and a y minus OB minus x. So you just add them together. But you have to go through all of this. This seems to be a cost that maybe we can be more smart about. Hold on, I'm hungry. I need to get food. If it's a 0, I can calculate, right? I can calculate. And if it's 1, basically, with the 0 on the right hand side, I need to get all of them, but it might not be possible. Maybe I have a better way. So essentially, we have left and right. We can put them together, like left and right, put them together. I have the total. Right, if the total is smaller than what is needed, then this is not possible. Right, and if the total is equal to what is needed, then you only have one way to include all of them. Right, it's only when the total is larger, then you have this problem of choosing which side is which. And you know how many is on one side or how many is on the other side, and then you just need to figure out what will be the. So we know the total combinations. Maybe we can go the reverse idea. We know the total combinations. Can we quickly find out what is the not allowed? Not allowed would be just not enough. I don't really think that's that easy to compute though. Yeah, like if I have the number I need to hit, right? Like I know the in between, so I know what is the number I need to hit. Yeah, and I know the number I need to hit, and then we just say it needs to be smaller than that. So I have the number smaller than that. That's kind of the limit. I want to find the number of combinations that's not possible, right? So we say not possible. One side is 0, right? And the other side is the other number that's not possible. One side is 0 and the other side is a number that's not possible, okay? Why would your number not possible? I feel maybe easier. Number not possible. If it's 1, I know the number not possible. No. So here's the idea. If we need to get 5 or more, right? Then so not possible one or 4, right? Anything smaller or equal to 4 is not possible. No, I'm gonna say this side is 0, this side is 4. Well, this side is 1, this side is 3, this side is 2, this side is 2, this side is 3, this side is 1, this side is 4, this is 0. That's the 4 different scenarios. That's not possible. What if on the left, on the right, we don't have 4? Minimum of these. Let's actually just add this up. When this is 0, like when this is 0, how much this one can get? Right? When left is 0, how much the right one can get? And then when right one is 0, how much this can get? And then you just add them all. Well, how do you add them all? No, you don't have 4. You have less than that. Totally fine. That's what you have. Now I see another loop. That might cause it to time out though. Oh yeah, the left is some value. When you take it off, right? The left hand side will take it off. And let me see how much the right needs. Right, and then it will decrease. But On the right hand side, we can add all of them, right? The minimum is 0. But we can add 1, we can add 2, we can add 3, so have a minimum, right, until we add all of them. So yeah, so I know how many we need to add. Let's say we add all of them, and then decrease again. Well, we'll add all of them until here. And then it's gonna be, has to be at least a 1. So the number to add decreases. Number to add decreases. And then add nothing. At a certain point, you cannot add anything. Once it has 0, we'll have yeah, have 1, 2, 3, 4, whatever. I don't have that much to add. So here, we have that much to add. Yeah, because I already considered it. I already considered it. On the left hand side will be how many is above. The number of times above multiplied by the right. Above equal. And then up until it's 0, right, we'll have this range to 1. From this, you'll have I require this 1. No, require this 1. And then require this 2 additional. But the choice is smaller, right? Now the choice will be total amount minus 1. down this one, problema minus 2. Until this is 0 and that is 0. Like so. Whoever gets to 0 first. Okay. I'm gonna do 01. All right, let's put this into practice. Okay. So I have this. This is actually not true. It's not -1. So I have index equals 0 on the high, index is 0 on the low. I want to know how many ones are in between. So what I do is I do index high minus index low minus 1. So this is the total number in between, right? And then I need to minus the 0 count, right? So the 0 count, but the 0 count including the two things, so I need to minus 2. So in total, it should be minus this plus 2, which means we're gonna plus 1. That is the total in between. Case in point, if this is 1, right? Then the 1 in between will just be high minus low. Right? High minus low. I actually feel this is not right. If it's 0, 1, 2, high minus low is 2. Hold on. it doesn't feel right. Let me think again. 2 minus 1 plus 1. Okay, so yeah, that's... Oh, so they pointed to the same one. When this is 1, it's actually a little bit complicated. Yeah, it's a little bit complicated. If they're pointing, if the high and low are pointing to the same thing, right? It's actually complicated. Because if 0 count is 1, high and low point to the same thing, then 1 in between is actually right. 1 in between is 0. Right, we don't have anything. Now, if 0 count is 2, right? 0 count is 2, then this one would just be like 1, 2 plus 1. Yep. So we have low and high like that, and then high minus this. I'd say 2 minus 0 is 2. 2 minus. Okay. Yeah. I feel like this is right. Okay. This is right. Yeah, 0 count is 3. Then the so I'm saying 0 count is 3. So it should be minus 2. 0, 1, 2, 0, 1, 2, 3, 4. So 4 minus 2. It's actually right. I think it's right. I think it's right. Because let's do it one more time. Right, this is the total in between. Right, the total in between, and we actually this one minus 1 is the total in between, and we don't minus any remaining 0, so just ZC minus 2. So yeah, I think it's right. So we have 1 in between, and then we need 1 on the left. Okay, how much 1 is on the left? So to find out the 1 in the left is just the 0 indices low, right? And low minus 1, right? So it depends on if low is equal to 0. So we don't have anything to the left. So what we're gonna have is 0 indices low minus 0, right? So this minus 1 in between. Is that right? Because I want to know the, so 0, 1, 2, 2 minus 0 is 2, and then minus 1. Right? Yeah, so whatever you are, you will 0, 1, 2, well, minus 0, 1. Hold on. So I am at, let's say, position 3, and then we have, so 0, 1, 2, 3. Actually, it should just be this. There's no minus, because it's minus this, minus 1, right? And then minus 1, yeah. So otherwise, then we have a 0, and this is low. This is low minus 1, right? So that's 2, and that's, we have to minus 1. Right, so there's a 1 on the left, and then 1 on the right. High. Indices size minus 1. If it is, then it's gonna be s dot size, right? So it's the last one. So s dot size minus 0 indices high minus 1. Otherwise, it's going to be 0 indices high plus 1 minus 0 indices high minus 1. Alright, so I got a 1 in between, got a 1 on the left, and I got a 1 on the right. Now what we do is to say if ZC times ZC is larger than 1 between plus 1 left and then plus 1 right, then we just continue. Because it's just not possible, right? It's just not possible. Otherwise, then it is possible. And we need to know what's the extra, right? Extra will be ZC times ZC is the, no, not extra, it's additional, right? Additional is, that depends, right? So ZC times ZC minus 1 in between, right? 1 in between. But this might be a negative value, so we should do a 0 or this, right? So this tell me how many additional do we need, right? How many additional do we need? Okay, so we have the number of additional that we need. So now what we're gonna do is we will start from this, take all on one left. So one left, so this is the additional that we need. So we'll do one left all the way to the additional. We'll see how many we'll have on the left hand side. Right, so this is a left one left is no smaller than additional. So rest of plus equal 2. So we can do all this multiplied by, can be a max, again 0. So one left, I have one left minus additional. Okay, so if additional I require is 2, okay, so like on the left at least is 2, and then I left have 5, so we're gonna do 5, 4, 3, and 2, right? So basically it's 5 minus 2 plus 1. I have plus 1 because it's including the additional, right? So all of those, the right can just pick whatever they want. Okay, so now what the point is take as many ones on the left such that we can take any count on the right. Actually, I just realized this is not right, because this is the number of 1 on the right, but we can also do 0, so we can plus 1 because we can do 0. All right, so on the right hand side we can do 0 or the count, right? Okay, yeah, this looks good. Now next is the number on the left, right? The number on the left is not enough. So the number on the left is not enough to cover additional. Right, we need help from the right. So what we know is the help from the right start with 1. Okay, so yeah, we always start from 1, but there is a thing that so the left is basically additional minus 1, right? So we'll do at most, additional all the way to 0. So it's just going to be 0 to additional minus 1. So we have additional steps, right? We have additional steps. And all we need to know is, like at the most is additional steps. So on the right-hand side, on the right-hand side, we start from, because initially I can do whatever, right? I can do all of them. But now, the left, we are keep decreasing. So we're decreasing, it's within. So right need at least one, right? At least one. So which means on the right, what we need is at least one. So we can do 1, and 2, 3, 4. So it's just the one right? That's the first one. And then we'll plus 1 right, minus 1, plus up until right, so that's the first step, that's the second step, and all the way until we have 1 right minus additional. We have additional steps. Right, minus additional. So this is always start is addition minus 1. Is additional minus 2. All right, and then at the end is the left is 0, right? Which means the right need to support the completely additional, at least additional, right? At least additional. And how many more do we have? If additional is 2, right, and then right I have, let's say 4 in total, so I have only 2. Yeah, so this is right. So we'll do this, but this is it might be negative, so it has to be the larger of this and then 0, right? So the left can start with additional minus 1 and go down all the way to 0. The right can start with 1 right and increase, and also the right and also decrease. The options, right? The options, the number of options on the right can start with this and also decrease until 1 right minus additional. Right. So here we're gonna say is rest, so plus equal to, it's gonna be 1 right, plus and then do another one. It's the minimum options. So minimum options on the right shall be the maximum of 0 and 1 right minus additional, right? And then it's gonna be just minimum operation right, minimum operation right times this right plus 1, this is the total number, and then divided by 2. So that's the other side of the equation. I am not sure if it's right, honestly. I am not. Because I'm saying so if 1 left minus addition plus 1 is good, so I can go all the way to 1 right. And then I start to decrease, right? Start to decrease. And the minimum operation on the right, I need to know 1 right minus additional. Let's say minimum is 0. Okay, minimum is 0. And the 1 right, yeah, this doesn't feel right to me. This is like the left. I'm decreasing, right? I'm decreasing, and then we're saying we can. Yeah, that's actually not right. Depending on the starting point on the left, right? Depends on the starting point on the left. Minimum operation on the right. And now we can also do a maximum operations on the right. Right, maximum operation on the right after the left cannot supply is going to be the minimum, right? The minimum of additional minus 1 or 1 left, right? The minimum of the 2. And then we need to do additional minus this. That's the that's what's required on the right, right? That's what's required on the, because on the left I'm supplying all of them, right? I'm supplying not all of them, I'm supplying this much. So if I supply this much, then on the right, what's the maximum number of operation we can do? So the maximum operation we can do is going to be, so the additional, right, minus what can do this, and this is what on the right hand side need to supply, right? And if 1 left is additional minus 1, now if its minimum is going to be additional minus 1, then the maximum number of operation is going to start from 1, right? And start from a 1. So what I need to know is what this is, how many we need to start with. And then we have the 1 right, it's a total on the right, minus this, where we need to start from, right? Minus where we need to start from, and then plus 1. This is the maximum operation on the right. Now this might become 0, so I need to also do an std max this and this. Right, so this is the max operation on the right. It could be 0, like if 1 right minus whatever this is not going to be right. Like if like additional minus this is the minimum needed, right? And then the minimum needed is going to be a big value, right? And then we cannot supply it, right? We cannot supply it, which means like if we take everything on the left, right? If we take everything on the left, but it's still not enough, then it's going to be a 0 max operation. And if the max operation is 0, then 1 right minus original, that's going to be 0 as well. Because 1 right minus additional is just like if the left is 0, then all the additional has to be on the right, right? All the additional has to be on the right. Then the number of operation is 1 right minus this. I don't know. This is kind of how I'm conjuring it right now. Then what? Then you just do this, and then you move on to the next one. Move on to the next one, move on to the next one. Alright, so what we're gonna do is we'll return res, and then we test this, and if it does not work, we're just gonna copy and paste, and then try to figure out a different solution, maybe. Yeah, I definitely won't say it's hard, but it's just a lot of logic here, and I have some issue. What the hell? And if you thought anymore, I'm telling you now, objection overruled. Here we go, yeah, it'll be negative. So this actually has to be not 0, but this one minus 1. Like the minimum has to be like that, right? This is from 0, and then if ZC is 2, then the minimum is going to be 1. So okay, so I change that. Change this to ZC minus 1. It's not right. It's actually pretty wrong. Alright, I don't know. I'll have to copy and paste. It says enumeration, which is just another way to say brute force. I guess brute force works. I'll be very pissed if it is brute force. So we'll do it some other day. It looks like brute force to me. Look at this. Actually, I'm not sure if it is brute force. Maybe it is, maybe it is not. We can actually look. What is this? Maybe prefix. This is to record. This is to record the index. The previous 0, right? So like if current is 0 and the previous is 0, so we'll set it as to I. So that's like that. And if not, this is going to be the previous one. So that's like the 0. What's the index of the 0, right? I don't know.